For what range of values could the constant k have in this function so that this function decreases for all values of x? Now, if this function decreases for all values of x, then the slope at each point on that function will also be negative. By looking at the slope function, we'll be able to discern for which values of k that function decreases. So first of all, we need to find the derivative of this function, which will give us that slope function. Using the quotient rule, where u is equal to x plus k, and therefore u dash is equal to 1, and v is equal to x squared plus k, and v dash is equal to 2x. And the formula for the quotient rule is here. We will just substitute all these numbers. Simplify this, but be very careful with the brackets and the negative signs. So we've got x squared plus k minus 2x squared, and there's another minus here for the because there's a minus in here, and you're going to multiply 2x with the k. Again, simplifying the numerator, we'll have minus x squared minus 2kx minus k. And so this is our slope function. But we want our slope function to be decreasing for all values of x. So we want our slope function to be less than or equal to 0. And this will be satisfied if the numerator is less than or equal to 0. The negative terms here beg us to change it to positive terms, and we can do that by multiplying each term by a negative. So we end up with positive terms, but it's now very important that we change the signs once we've done that. So we're looking for values of the y of this function to be greater than 0. Now this is a quadratic function. When will the function be greater than 0 or be positive? So a quadratic will only be positive if it has no real roots. No real roots. And we can determine if the quadratic has no real roots by looking at the discriminant. Remembering that if the discriminant is less than or equal to 0, there will be no real roots. If the discriminant is equal to 0, 1 double root. And if the discriminant is greater than 0, then there are 2 roots. So since our quadratic is this, I've just written it below, the discriminant will be b squared minus 4ac. And substituting this, we'll get 4k squared minus 4k, which gives us this factored form. And as we said, for no real roots, this must be less than 0. So what are the values of k on a sign diagram? Obviously, k cannot be 0 and k cannot be 1. And here you can see that if the values of k are greater than 1, for instance 2, and we substitute 2 in here, this will become a positive value. And similarly, if we choose a value between 0 and 1, we will actually get our negative value. And also a positive value if it's below 0. So we can now say that if fx is forever decreasing, then k must take the values between 0 and 1. And so we can write this down as k is less than or equal to 1, or k is less than or equal to 0. So what does all this mean actually? You've just figured it out algebraically. Let's have a look at it graphically. Here I have chosen k to be 2. As you know, that is above in the positive. And as you can see, the function here decreases, and then it increases here and starts decreasing again. So it does not always decrease. On the other hand, when k is equal to 1, our function indeed decreases. The slope decreases on this side, and then we start again, and the slope decreases on that side. Also, if we make k equals to 0, we'll see a similar pattern here on the function. It's decreasing on both sides. And now I used a number for value for k, which is -1, and that obviously is from below the sign diagram. If we have a look over here, it is now positive, and see what happens to my function. You can see that it looks completely different. It's definitely decreasing on here, and it's decreasing here, but then all of a sudden it increases, and it also increases on that side. The function looks completely different. So if I bring all of those functions together, you can definitely see that the value of k, if you want the function to be decreasing, has to be either 1 here or either 0. So I hope I explained that question really well to you. If you have any other questions you'd like me to explain, please put it in below in the comments, and I'll try to work out the solutions to that as well for you. And please subscribe to my channel so that you can see the next lot of videos that I'm making.